Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Walker at Middle School, and we're going to be working with the surface area and volume of rectangular prisms in this video. And so, just a quick little math to warm that brain right up. Do some multiplication. So let's do 2 times 3 is 6 times 4 is 24. 2 times 3 is 6 times 5 is 30. 2 times 4 times 5 is going to be 40. Add those three together. So it would be 70 plus 24 is 94. All right. Always making sure that you can drive that calculator car carefully. Let's actually multiply. So we got 2 times 6 times 7 is going to be 84. We have 2 times 6 times 8. That's going to be 96. And we have 2 times 7 times 8. That's going to be 112. Add those three together, so don't forget that. And in total, just like I had before, add those three, and we have 292. Last two, real quick. Let's do 3 times 13 times 8.5. Alright. So again, make sure that you're driving that calculator car carefully. And also, if you would like, you can use that Desmos calculator to be entering in those values for yourself. Alright. So, now that we have our brains warmed up, some of these key ideas that we're going to have for this are going to be as follows. So it says the surface area of a solid, that's talking about a 3D shape. It's just going to be the sum of all of its sides. So it's talking about the amount of space to cover, or to wrap. So if you think of wrapping a present or trying to cover a table, that's kind of the idea that we have for this. So the three dimensions that we need to find the surface area or the volume is going to be the length, the width, and yes, that's right, the height. So once you have labeled those values, you must keep those same values throughout the whole problem. So as soon as you label that, say, okay, this is going to be the length, you have to say whatever that value is, that is now your length throughout that problem. And you'll see it in this example that I have here. So it says the surface area of a rectangular prism is found by using the formula, and that says surface area is equal to 2 times the length times the width plus 2 times the length times the height plus 2 times the height times the width, where we have L, again, is going to be length, the width, and the height. Alright. So, in this first example, let's do it like this. It says, well, let's label first. So let's say that's the width, let's say that's the length, we can say that's the width, and that's the height. So again, this is what I mean when I say label them. So you have to say, okay, I'm going to say that the length in this problem is 7, the width is 9, and the height is 4. That means throughout this entire thing, I have to use those specific values. So we write the formula, 2 times the length times the width, plus 2 times the length times the height, and don't forget your homework at the end. So then it says substitute, so we have surface area is going to be equal to, and it says 2 times the length, so we're going to have in parentheses 2 times the length, which is 7, times the width, which is 9, plus 2 times the length again, so it's 7, times the height, which is 4, plus our height, so 2 times our height times our width, so times 9. Alright, So again, make sure you're giving yourself enough space if you need to, or if you need to write another line, you can, whatever works for yourself. So then it says simplify, and so let's do, again, these multiplied together, and so we're going to have 14, because we do 2 times 7, 2 times 7 times 9, that's going to be 126. And we do 2 times 7 times 4, that's going to be 56. And we have 2 times 4 times 9 is going to be 72. Again, adding those together now, we have 126 plus 56 plus 72. It's going to be 254. And now we're saying that the surface area is going to be equal to 254 what? Well, for this problem, it would be centimeters squared. So again, remember that anytime we're talking about area, your units have to be, so area, including surface area, so surface area is always going to be units to the second power. So now for the back of this page of the rectangular prism notes, you want to make sure you're saying this is going to be for volume. So we're going to be talking about how to solve for the volume of a rectangular prism. So then we're going to say that the volume is the measure of the space occupied. Occupied by a solid or to fill a solid. So there's some keywords for that. And we're going to say our units will be cubic units or units to the third power. And then we're going to use that formula for the volume of a rectangular prism. We're going to say the volume is going to be the length times the width times the height. So we're going to say L is length, W is the width, and H is the height. So now in this first example, you want to make sure you follow these steps. So first, we're going to label our dimensions. So we're going to say 7.2 is the length, 6.8 is the width, and 2 is going to be the height. So we did the labeling. Now we write the formula as V is equal to L times W times H. We substitute in our values for our variables. So we say volume is equal to, and then we say 7.2 times 6.8 times 2. And then we simplify, so we get volume is equal to 97.92, and we have to include the units, so we say units to the third power. And then for the second one, same setup. You want to make sure that you are first labeling your dimensions, writing the formula, and it will just be like that first example. So make sure that you can label, substitute, and then simplify. At the bottom, it says what happens when we change one dimension of the attributes. So we're going to take and say for surface area first, what happens when we double the height? So on the front, it said our surface area was 254. That was that surface area on the front. But now let's see what happens when we double the height. So our current height was 4. That means our new height is 4 doubled, which is 8. And so again, similar setup, we now have to solve for the surface area of this new prism. So we're going to say the surface area is equal to, we have 2 times the length times the width, plus 2 times the length times the height, plus 2 times the height times the width. We substitute in our values for our variables, so we have 2 times, we're going to have 2 times 7 times 9, and we have plus 2 times 7 times 8, and since that's we said 8 is our new height. And so then we have 2 times 8 times 9. And so then we just simplify carefully like before. So we say 2 times 7 times 9 is going to be 126. 2 times 7 times 8 is 112. And then 2 times 8 times 9 is 144. Add those three together. And we're going to get 382. And we have centimeters squared. So we're trying to see, is there a pattern between when we change one of the dimensions for surface area? And so we say no pattern. However, when you try it for volume, on the front we said, or on that new height is going to be 8, but our volume originally was 252. So that means our new height is still going to be 8. And so let's see what happens when we double the height. So that means we have our formula, which is length times width times height. We substitute in our values for our variables. So we say length is 7, width is 9, and our new height is 8. We just multiply those three together to get 504, and then centimeters to the third power. So now we can say, all right, what happens when we double the height for volume? What happens to the volume? So we're going to say, all right, if you double the dimensions, you double the volume. Again, this is only true for volume. However, for surface area, it does not work. So you can only do this for surface area. So again, if you double the dimension, you double the volume.